Hi, I'm Nick Benavides, and this is my video final for physics class 1401. Okay. What we're going to be looking at are the 10 questions of the take-home exam. And here's the first question. So if P plus A over V squared times V minus B equals RT, if P is pressure and V is volume, find the dimension of A and B. So this is a dimensional analysis question. So the way I figured it out is first I found out that P equals force divided by the area, which in dimensional analysis equals to mass, length, time to the -2 divided by length squared, which also equals to mass times length to -1 time to -2. So that's the same as volume equals L to the power 3. So if pressure equals area divided by volume squared, that's also equal to A area equals pressure volume squared. And in dimensional analysis, that equals to mass length to -1 time squared length 6. It's also equal to, simplified, is mass length 5 t to the -2. So A equals mass length 5 t to the -2, and B is the same as volume, so it equals L to the power of 3. And that's question number 1. Now on to question number 2, which is a vector resolution. So basically what this one is you have to find the x and the y component of each of these vectors. So it's pretty simple. So x would equal 12 cosine the theta, which is 60. As the same for y, but instead of cosine, it would be 12 sine 60. So we simply just plug that into the calculator. So we find x first, so that's 12 cosine 60, and we get 6. And y is 12 sine 60, which is 10.4 as our answers. Now we just do the same thing for these next two as the same as we did for these. So what we see on this next vector is that it's towards the opposite direction, but since the x and y are the same, it is exactly the same. We solve it the same as we did this one. So it would be for the x component, which is here, and the y component, which is here, we would do 15 now, because that is the newtons, cosine 20 for the x, and then for the same thing for the y component, but instead of cosine, we do 15 sine 20. And we simply just plug that into our calculator. 15 cosine 20, and we get 14.1 for the x component. And we do 15 sine 20, and we get 5.1 for the y component. Now, for the third and final vector, what I like to do on these is, since it's on the bottom, I usually just like to turn the paper like this, so it can be equivalent to these other vectors. And so what I can do is, now we know that the x component is this, and the y component is this. So we can know that x is going to be this side, 25 cosine 30. And we know the y component is going to be this side, so it's going to be 25 sine 30. So this is our x and this is our y, and we just simply plug that into the calculator. 25 cosine 30 is 21.7. And then the component is 25 sine 30. It's 12.5. And that is questions 1 and 2. Now, here is number 3. So it's a projectile motion question. You kick a ball from ground level with an initial velocity of 60 meters per second. So as soon as I hear that, as soon as I read something, it gives me a velocity or a percentage, I like to write it down. So V1 equals 60.0 meters per second. So now we already know that. So it has an initial velocity of 60 meters per second at 20 degrees. So it's at 20 degrees. Above the horizontal to pass to your teammate who is standing 100 meters away. So our first question is A, time the ball is in the air. So what I do is, it's kind of like the vector problem. So you have your initial velocity. So you go ahead and do 60 sine, because it's horizontal, times your degrees, which is 20. So 60 sine 20, and you plug that into the calculator and you get 60 sine 20, and you get 20.5. 20.05. No, just 20.5, yeah. And then what you do is you add 1/2 of the, because it's going down, so you do 9.8 negative, since it's going down, which is your gravity, divided by 2, which equals negative 4.9. So you do what you got here, 20.5, plus your negative 4.9 t squared. So you're solving for t, which is time. So easily what you do is you do 20.5 divided by 4.9. Yeah, 4.9. And you get 20.5 divided by 4.9. You get 4.2. And then, since it's asking for total time in the air, this is the time it takes to reach its maximum height. So simply, all you do is multiply that times 2, and you get 8.4. And that is the time the ball is in the air, 8.4 seconds. Now, you want to solve for the maximum height. So the maximum height is, you do your initial velocity, 60.0, times 1.38, minus your gravity divided by 2, which is negative 4.9, times also that 1.38. And you plug that into the calculator. So 60 times 1.38. 60 times 1.38 minus 4.9 times 1.38. 76.5 76.38. 76.38. And that is your ball's maximum height. Now, the horizontal distance is very simple. All you do is your
Height in feet or inches?
Meters. So now, for question C, the horizontal distance traveled. It's very simple for this one. All you do is similar to what you did to find the time the ball is in the air. So you do your 60 sine 20 times your 4.09 times 2 . So let's go ahead and plug that into the calculator. 60 sine 20 times 4.09 times 2. And you get 8.18. No. Sorry. 60 sine 20 times 4.09 times 2. And you get 167.9 meters traveled. So now for question B, it asks, does your teammate receive the ball? So since your teammate's standing 100 meters away and the ball travels 167.9 meters, the answer is no, your teammate does not receive the ball. So now on to question number 4. Another projectile motion question. Alex, a rescue pilot, drops a survival kit while her plane is flying horizontally at an altitude of 2,000 meters with a forward velocity of 150 meters per second. How far in front of the explorer should Alex drop the supplies? So what I did was I found the equation was the square root of 2 times the change in y over gravity. So I plug that in, so y equals the altitude, which is 2,000 meters, and gravity is 9.8. So I simply, meters per second. So I simply just plugged that into the formula. So 2 times 2,000 over 9.8. Square root equals 20.20. And then you have to find the change in x equals Vx. So it equals the 150 meters per second times what you got here, which is 2020. So 150 meters per second times 20.20 equals 3,030. So your answer is 3,030 meters in front. They should drop the supplies. Now, question number 5. A 3.5 kilogram block on a smooth tabletop is attached to a hanging block of mass 2.8 kilograms. The blocks are released from the rest and allowed to move freely. So it wants me to find the acceleration of the blocks. So the formulas that I used were sum of Fx equals t. Ma equals t. (3.5) A equals t. So the sum of Fy equals Fg minus t, and Ma equals Mg minus 3.5a. So I plugged that into the formula, and I just did 2.8a, which is found here, the kilograms, equals 2.8 times gravity, 9.81, minus 3.5a. So it equals 6.3a, simplified, equals 2.8 times 9.81. So A equals 2.8 times 9.81 divided by 6.3. Plug that into the calculator. 2.8 times 9.81 divided by 6.3, and you get 4.36 is the acceleration of the blocks, and it's accelerating downwards. So 4.36 meters per second down. Downward just is the where it's accelerating. So next is the tension of the string. So for B, 3.5a equals t, as one of the equations I wrote here already. So A is the acceleration, since we already found it. So it'd be 3.5 times the acceleration, which is 4.36, equals t. So we just plug that in, multiply that. So 3.5 times 4.36, 15.26 Newton. Is a super dart of mass 30 grams traveling at 250 meters per second strikes a steel plate of 30 degrees with the plane of the plate. It bounces off the plate at the same angle and the same speed of 250 meters per second. What is the magnitude of the impulse that the plate gives to the bullet? So the formulas that I used were impulse equals mass times velocity final minus velocity initial. So that is mass equals 30 grams times velocity final, which is at the same speed, which is 250, minus velocity initial, which is 250. So that equals 30 times 0, which equals 0. So the impulse equals m times velocity final cosine of theta minus velocity initial cosine of theta. So that is the same, similar to what we did here. So it'd be 30 times velocity final, which is 250, cosine, we have our degrees up here, 30, minus velocity initial, which is 250, cosine of 30. So this minus this equals 0, so it's the same. equals 30 times 0, which equals 0. So the magnitude of the dart is 0. A 0.080 kilogram pet lab mouse sits on a 0.35 kilogram air track cart. The cart is at rest, and as is the second cart with a mass of 0.25 kilograms. The lab mouse jumps to the second cart after the jump. The 0.35 kilogram cart has a speed of 0.91. So the question is, what is the speed of the mouse at the 2.5 cart? So it's asking, when the mouse jumps to the second cart, what is the speed of the second cart? So the formulas that I used was, so the P before equals M1 times V1 plus M2 times V2 plus M3 times V3 equals 0. So there's no M3, so we can just go ahead and cross that out, but just for sake of the formula. And then P after would equal M1 times V1 plus M2 times M3, velocity 2 squared, times velocity 2. So since we're looking for velocity 2, the P before equals P after. So it would be 0 equals, and now I'm just going to go ahead and plug in all the numbers into it. So 0.35, which is the first cart, times the initial velocity, which is 0.91, plus cart 2, which is 0.25, plus the weight of the mouse, which is 0.080, V2. So we add that together, 0.35 times 0.91 plus 0.25 plus 0.080 equals 0.6485. So now all we do is this, we do negative 0.35 times 0.91 divided by 0.33. A 5.0 kilogram metal ball at rest is hit by a 2.0 kilogram metal ball moving at 4.0 meters per second. The 5.0 metal ball moves forward at 2 meters per second, and the 2 kilogram ball bounces back at 2 meters per second. So question A is asking for the total kinetic energy. So the formula for kinetic energy is 1/2 mass times velocity squared. So that would equal to 1/2 mass 2.0 times velocity, which is 4.0, squared, equals to 16. So the answer for A is 16 joules. So total kinetic energy after collision, so that would be 1/2 5.0 times 2.0 squared equals to 10 joules. And now the energy transferred from the small to the big, all I did was 1/2 2.0 times 2.0 squared equals 4.0. So the answer is 4 joules. Now on to the final question, number 10. A chicken is running in a circular path with an angular speed of 1.52 rad per second. How long does it take the chicken to complete one revolution? So the equation for a revolution is 1 revolution equals 2 pi rad per second. So since we already know the rads per second, it would be t time equals 2 pi divided by the 1.52. So we just plug that into the calculator and we get t equals 4.13 seconds. So that is all 10 questions of the take-home exam. Thank you very much.